Okay, today I'm going to talk about delivering JavaScript to World+Dog. That's right. Okay, so we got startups, your next billion-dollar unicorn startup out there. Enterprise SaaS, big space for that. The quickest way for a startup to get some value down to their customers is JavaScript. Everybody's got a browser on their phone, on their computer. Lots of JavaScript developers out there. So let's start building our startup. Real simple pitch. You go to the customer. Hey, listen to this. You just drop this one line of JavaScript on your site. We're going to give you some business value in return. Really simple. In Optimizely's case, this is A/B testing. So, hey, pets.com. Don't you want to know what sells more pet food? Is it puppies or is it kittens? Our JavaScript will tell you and increase your revenue. So that sounds great. Great for the entrepreneur, great for the customer. What could possibly go wrong here? Yeah, so third-party JavaScript all of a sudden is being loaded on your site because the marketer thought this was a good idea. Great, and now this is a successful startup, $1 billion, lots of customers. This JavaScript is being loaded all over the web. And next thing you know, it's on lots of websites, lots of the top websites in the world. So, hey, if I want to compromise all those websites at the same time, maybe I should go to one of these third-party JavaScripts. That'd be a great economical way to get my attack out, get my payload out to as many places as I want with one compromise. So to tell you a little story about this, there was a startup that did this. Their business model was put JavaScript on your page, kind of like Optimizely, and get some business value back in return. The startup's called Gigya, and Gigya happened to have their DNS compromised. And after their DNS was compromised, all the sites like Forbes and a bunch of other media sites that were serving Gigya as JavaScript started serving Syrian Electronic Army payloads instead. Really clever. They got their political message out all over the web. Somewhere in the follow-through, they dropped the ball, and the best they could come up with is, you've been hacked. Could have been a lot worse than that, as I'm sure you could imagine. So, one of these startups, what does it look like? So here's a simplified architecture diagram of what an enterprise SaaS startup delivering third-party JavaScript looks like. There's still too much going on there, so let's simplify it down to what we care about today, which is creating JavaScript in your app and then sending it down to all the visitors of your customers' sites. So what does the threat model look like here? Pretty simple. All those places up there, compromise any of them, and that JavaScript's compromised. All those websites get compromised. Bad news. So we're going to walk through this in a little bit more detail, starting off with the simplest and most easily overlooked part of security, which is availability. Yeah, so any of these things get popped and your business is offline, you can't make money, your customers don't get value from your product. That sucks. So quick word of warning, protect yourself, get backups everywhere, be prepared for events like these, which have both happened in the past year. Dyn got DDoSed last October, and Dyn is DNS for a lot of popular websites out there, and so those websites went down. And then maybe you don't use Dyn for DNS, but you probably use a lot of third-party SaaS providers, and some of them probably do use Dyn, so they were down as well. So this trickled out and took out a large part of the internet for about 7 hours. And then earlier this year, S3 in East 1 went down for a while, all because of a small typo causing havoc across the internet. So have backups, have backup services even. All right, next, we all know about the weakest link, humans. And so there's a lot of humans involved in this threat model of just getting JavaScript down to browsers. So first off, your customers. Your customers are logging into your site. They're doing things, in our case, creating those experiments with puppies and kittens and goldfish and whatever. And then that's ending up as some kind of deliverable on their website, but it could be JavaScript. So out of all those customers, they're going to have probably their whole marketing department, all with access to your site. And then you give them all these roles, but they're marketers, so they don't care about roles. They want to get their job done. They all have admin. And so all of a sudden you have all these folks with backdoor admin access to the site going around the website admin. And any one of those, all it takes is them to have one crappy password that they used on all their other social network sites, and one of those sites gets popped, and then the attacker comes back, grabs that password off of Pastebin, and then compromises your customer's site through your service. Who do you think the customer is going to blame? You. You think they're going to renew their contract? No. All because of somebody choosing a crappy password that was not under your control. Now, with that, we're going to talk about authentication a little bit. Now, over to your employees. So we have a lot of admins and developers here, and to keep this site going. And if you're a small startup just getting this going, or even a medium-sized startup, all three of these roles may be the same person. Or you may just have a bunch of developers, and they have all of those roles assigned. Like, you want developers to be productive as possible. You don't want barriers in their way, especially with a startup. You're not profitable yet. You want to give them access to everything they need to get their job done, and hey, maybe we're too small of a target to get caught and get compromised. Well, if you do get caught, you can't buy your way out of it. You're a startup. You're done. You're just done. And so that risk-reward trade-off of speed for developers quickly goes away, I would say, by the time you hit like a Series A, or maybe if you have more than 10 developers. So what I would recommend here is, again, with authentication, which we're going to talk about in a minute, but also like one of the biggest things that developers and admins are using to get their job done is API keys and secrets. These API keys and secrets that's the keys to your production infrastructure. So like how does your build system deploy your infrastructure to AWS or to Google Cloud Platform or Azure, for example? That's a key. I'm guessing if you're a startup, it might be an admin key, because who has time to refine permissions? What about how you send emails to your customers? There's another API key. Or how do you configure your CDN? All kinds of API keys. All these are keys to your crown jewels, which is that JavaScript. So what are these doing in humans' hands? They really don't need to be there. In this case, there's a lot of nice software tools out there that help you manage secrets. CredStash, Confidant, KeyWiz. What all these do is they store your production secrets off in some secure store, and no humans have access to this store. That's the biggest, most important point here. No humans have access to your production secrets. Instead, you have developer secrets, which can have like a separate sandbox instance of whatever you're trying to do. So they can still build their development environment, but those production secrets never go to developers' laptops. They never have access to them. They need them for debugging. Maybe you make a one-off key that's time-bound, but don't give developers these production secrets. It's so easy for these to get leaked. One of the smartest developers I know, I saw once, this was a long time ago, incredibly intelligent, and he got security, but he put an API key in his dot files, and then he likes GitHub, so he put his dot files on GitHub to show off like how cool his dot file is. And then that key, guess who slurped up that key on GitHub? Yeah, that's right, not AWS. Somebody else got to it first, and then his access to AWS was compromised. Fortunately for him, all they wanted to do was mine cryptocurrency, so they spun up a bunch of EC2 instances, but that could have ruined his day like big time. But this can all be avoided if you're not letting developers get in the business of handling keys. DevOps is much better equipped to keep these in a good place in a secret store. All right, so over to your infrastructure. So this is where your application is. That's where most of those boxes are on that original architecture diagram. So all the different things that go from like your customer logging into your site, and then all the interaction they do with your product to create this JavaScript. Now, again, with startups, like with the smaller startups, they usually start off with a monolithic app just because that's the fastest to develop with. So maybe you make something in Heroku or Google Cloud Platform, and it's just one big monstrosity that grows over time. Even Twitter did this, Ruby on Rails. You may have read stories about the monolith over the years, like millions of lines of Rails code, all just one big app. Well, when you have one big monolithic app, that means all of that code is just one big blob. There's no access control, there's no isolation there. So if you can get this big blob of code to do something you want, it may have access to everything that monolithic has access to. So all of your customers' data, all of your customers' secrets. So with these, what I recommend is find those secrets and isolate them out of this monolithic app. As your startup matures, they're probably going to want to get into microservices, break these things out. That works great for security and isolating these secrets. But you can actually be a pioneer in doing microservices at your startup by make the first microservice, which is a secret store. You have customer secrets. You probably want to encrypt those at rest, but what good is it if the encryption key is accessible to your entire monolithic app? So you can make a tiny service, all it does is encrypt, and then you have your first microservice, you have your customer secrets isolated, everybody's happy, you show off to the rest of engineering, hey, we build cool shit in security. Another one would be password hashing. So password hashing, it takes a long time. You do it in a managed language like Python, that password hashing could go on all day, but you could spin off to a microservice where that runs in native code. Then all of a sudden you have a fast microservice. Security's building these really cool microservices. Then other engineers want to get into security, hey, because they're building these awesome microservices while we're over here patching bugs in our big monolith. Now let's talk about authentication for a bit. So we talked earlier about customers and how that one bad password could ruin your day. And so a couple things you can do here. So we know passwords are bad, but we have some good password hygiene now, especially with like the recent NIST publication. So you can get rid of all those like clunky rules about passwords, like they have to have special characters and numbers and all that other junk. As long as you don't have some like lame compliance requirement for it, like just do away with that and like make a long password. Long password, it's hard to crack, and move the burden from the customer choosing a clever password, because they won't, to you. And your job is to at least get them to have that length of the password, but then try cracking the password yourself, or have a Bloom filter of all the like known leaked passwords on the internet. There's only like 20 million of them, which goes to a very small Bloom filter. And you can look up and see, is this a known compromised password? If it is, don't let the customer use it. Or an even simpler check, just don't let them reuse their old password. When they go to change their password, check it against their password history. Have you seen a hash of that password before? If not, boot it out. So passwords are cool, but still, it's just a password. Better is two-factor authentication. So that's simple. Use two-factor. Okay, nice. Well, some tips on two-factor authentication you don't hear very often. You have several options there. First off, SMS, send a code, SMS. Anybody ever heard of a problem with that? Yeah, that's right. It's ask Coinbase about that. They will, if somebody wants to get into your account, they can easily socially engineer their way into your cell phone provider, get access to your cell phone, and then intercept that SMS message. Don't even waste your time with SMS two-factor. If your customers are asking for it, like, don't give them something to shoot themselves in the foot with. Just don't even bother with it. A better alternative is TOTP. So this is an RFC standard for those little codes you get in like the Google Authenticator app or Duo app. It's a very small library. You can drop into your code really fast. So you don't need to pay a third-party service for it. It's great. It's good enough for customers. It's not the best in the world, but it's good enough. And that's probably as good as you need to be to get your customers to use it and to check their box looking for two-factor. You don't need to go farther than that. You may hear about services like that do all this two-factor for you, a third-party service. And so then they have the fancy push notifications that push down to your phone, and then you just have to swipe on your phone rather than entering that code. That's a little bit better user experience, but it's kind of a business trade-off for you. It's a better experience for your customers, but anybody ever heard of vendor lock-in? Once you've got all your customers enrolled in that third-party service, it's really hard to get them back out. Like, push notifications are not portable, and those vendors have no interest in making them portable. So they know that if they can get you to start using push notifications, you're never going to cancel their contract, because you're not going to go to all your customers and be like, hey, customer, like, I need you to go get all of your employees to unenroll from this app and install this other one and re-go through push notification. No, they're not going to do that. Instead, you're just going to feel pain as you start paying that vendor more and more money. Now you might think, oh, well, I'll just build my own push two-factor authentication. Please don't do this. Push notifications are incredibly difficult to get right. They're buggy as hell. If you, the security team, try and build push notifications, you'll become the push notification team, and you'll still be dealing with bugs all the time. And then when the rest of the engineering team hears about you, they're going to be like, oh, don't ever let the security team do anything. All they do is introduce buggy code. It's a nightmare. Stay away from it. Now, like, we might like these YubiKey things okay, these cool like little things you can plug into your computer. Great. But we're an enterprise SaaS startup, so we should build what our customers are going to use. Has anybody requested these? Practically never. If you're not on like bleeding edge, you really don't care about YubiKeys. So great idea in theory, but your customers don't want them. You give them the TOTP, you can do that in a week, call it a day. At Optimizely, we added TOTP into our product in a hack week. Just me and a couple interns, boom, it was done. No having to buy hardware, no having to integrate with the third-party service, none of that. Now, two-factor is cool, but still, you got a password in there, you got this TOTP. What would be even better is like shift all this authentication stuff over to your customer. And so that's where SAML, single sign-on, comes in. This is great. You just integrate with the standard, and then you can plug in your customer's Okta or one login or ping or whatever. This is great. Move all the burden to them for offboarding. They like it. As you get into bigger customer deals, which I'll talk about in a bit, they may even require this. So third-party code. At a startup, like, you don't have time to write all the code in the world. You may think you do, but you don't. And most of your code is actually not going to be written by you. It's going to be in third-party code that you use. And a lot of that is going to be open source code. How do you check the security of all this code? Like, if you think about the attack surface for your product, like 80% of it's going to be code you didn't write. Like, why not just go hunting for vulnerabilities there? And also, you find a vulnerability in this open source component, you could use it on Optimizely, you could use it on 10 other sites that use that open source component. So please don't overlook managing your third-party code. There's some great tools out there now, like really impressive startups that they'll scan your code, look at all of your third-party code that you're using. But, okay, that's nice. You tell me I need to patch a bunch of crap, like, go away. Nobody likes getting just a big to-do list like that. But they go one step further now where they'll actually go down into the code of this third-party library, and let's say on line 131, that's where they didn't do output encoding. It'll look and see, like, do you actually use that code in your product? Okay, no, you don't actually touch that function. You don't even have to worry about patching. And so this screens out so much of the work of like managing third-party libraries. So again, so the security team doesn't get this reputation of just creating a bunch of stupid work for engineering. There's even another startup that like they'll even offer to patch the code for you. So okay, I don't have time to update. Maybe it breaks stuff because it's a major revision. Well, they'll actually change that line where the security fix is, so you get just that security fix without all the other junk that comes with it. Really cool. All right, so you've built your JavaScript in the application infrastructure, and so now you're kicking it over to the CDN. And so like the CDN, so you're putting it up there typically for speed, because these have POPs all over the world. It has very short latency between your customer site and your JavaScript client. So this is really cool, but let's say you're an attacker and you want to go after New York Times, get your political message out. And then you look on there, you see it's loading Optimizely. Okay, and what's the URL for that? Oh, it's cdn.optimizely.com. Probably a smart first place to start. So that puts a big target on your CDN. And I'm also willing to bet you don't build your own CDN. That's probably not the business you want to be in. And so you're relying on a third party for this, and you're at the mercy of the security of these CDNs. So this is a tough situation. You got a big target on this thing, but it's a third-party service that you don't have that much control over. So this, like, in general, you want to isolate access and stuff, but it's absolutely critical with your CDN that you minimize how many people have access to it. Like, give your developers access to all your infrastructure, but CDN, like, just that's where you got to put your foot down. No access to the CDN. Developers want to look at it, be tourists, great, give them read access, or give them a, like, CDN sandbox to go play with. But the production CDN absolutely positively has to be locked down, minimize your number of CDN admins, save yourself a lot of pain later on. All these best practices, two-factor SO authentication, definitely want to, like, where do you start? Like, if you have 100 third-party services you're using, this is the place to start. Logging, for sure. And change management, like, so in a startup, you really want to avoid change management because you're trying to move fast. You don't want to bog developers down with bureaucracy. But the CDN, it doesn't need to change that often. And so this is a great place to have change management because the risk is definitely not, the risk-reward trade-off here, performance of your developers is definitely not worth it compared to the impact they could have screwing up your CDN. All right, so going down from your CDN, so you're delivering your JavaScript down from the CDN to your customer site. So just if you remember one thing from this talk, it's always load over TLS. Always use HTTPS for loading this JavaScript. It eliminates so many things out of your threat model that could go wrong. The JavaScript delivery can get compromised in many different ways. There's so many hops on the internet between your CDN and your customer site. So starting off, this they're not going to do it themselves. So make sure when you give them, hey, just drop this one line in, make sure it actually has HTTPS in it. And then right there, you're giving them a secure default. You don't need to wait for the customer to decide to make this secure, give them the choice of making it secure. Just serve HTTPS only. Don't give them the option to opt out. For Optimizely's case, it was a startup for a while, and then we've had this on for about a year. Now about 70% of our CDN traffic is over HTTPS. And we're at the point now where we're just going to pull the plug on HTTP. People are going to get a chance to opt out, and maybe they'll have their own CDN-alternate security or CDN HTTP that they load from. That 1% can opt out. Everybody else gets HTTPS all the time. You can flip on the HSTS header. That tells browsers, no matter what this site says, load it over HTTPS. That's great. So a couple other stories here on TLS. So one thing that could happen is your DNS could get compromised. We heard about that with Gigya earlier. And another one is BGP. So this is kind of a different attack. So the one with Gigya, it was okay, compromise this third-party JavaScript, and then I compromise all these sites for everybody. But another interesting attack would be a BGP attack. So what if I want to go after one organization and just their network? So I could do a BGP attack and then point cdn.optimizely.com over to my malicious server. And then that malicious server could serve down a different payload, still JavaScript, but a different one that has my malicious payload in it. And so in this organization, maybe they have their security game up pretty good, and they're doing intrusion detection and prevention and filtering and everything, but Optimizely is loaded on a lot of websites that their organization's going to on a normal basis. So and it's JavaScript, it's a bunch of JavaScript, so let's just whitelist that. If we see JavaScript coming from cdn.optimizely.com, then that's okay. Well, the attacker can get their payload through because of that rule. So this is another way to get in. But again, HTTPS gets around that. You won't be able to, the BGP attack, they won't have the Optimizely certificate. Now, with TLS, so why not always do this? Some customers you'll run into, especially e-commerce sites, speed is everything. And 100 milliseconds costs revenue. It affects their bottom line, how much time people spend on a site. And so they're oh, we can't afford TLS because it's too slow. So let's do a little myth busting here. Great site is tlsfastyet.com. Short answer is yes. You got to do some tuning, but you can make it really, really fast. So a couple ways this happens. One is people think oh, well, the crypto is what slows down TLS. But now the crypto is super fast. AES built into processors. The handshake is super fast relative to everything else. The performance cost comes in with latency. So if you're on Wi-Fi on your laptop, it's going to be fast. But as your customers go global and you have handsets on 3G networks, those round trips are going to get expensive, and then that's where you see latency. And unfortunately with TLS, you have a lot of different back and forths, a lot of round trips that all introduce latency, and that's where people feel the pain of HTTPS. So that's where the tuning comes in. That site is tlsfastyet.com, walks you through this, especially with what CDN support what, but a lot of it comes down to getting rid of some of those round trips in TLS to cut down on the latency there. You can really, really cut down the latency big time. Now over to the browser. So You have this third-party JavaScript. It's doing something on the customer's or the visitor's page when they visit it. So just a couple things to remember here. Like it's very easy to want to like store data about the user, but anything you're putting in these cookies and local storage, it's all going to get inspected. Your customers are going to look at it and see what kind of liability they have. Your visitors are going to look at it and see like, hey, what kind of creepy stuff are you trying to do to me? Privacy advocates are going to look at it and be like, yo, what kind of creepy stuff are you trying to do to everybody? Governments are going to look at it and be like, what are you doing running afoul of our privacy regulations? So I would highly recommend avoiding putting private data in there. Now the flip side, the argument could be, well, if I don't put it there, I store it server side. That's kind of creepy too, like aggregating a bunch of data about everybody server side. So you could actually make the case, well, it's for my product, what if I just store all this private data in the cookies? And that way it never goes to the server, and then I'm more pro-privacy that way. The user's always in control of their own privacy. So interesting trade-off to go into. It's going to depend on your situation. Of course, if you do store data there, integrity checks, don't trust anything coming out of there. Everybody's going to tamper with it, especially bug bounty researchers. If you do got to put something in there, sign it on the server, put it down, and then check that signature later on. Now, content security policy. This is a big deal for third-party JavaScript. Now, as being a startup, you may be writing like JavaScript and not TypeScript, so you're just writing like some really messy, nasty JavaScript to get your job done, and you're going to be throwing insecure functions left and right like eval. That's not going to fly with a content security policy. It's also not going to fly with big customers. They're not going to put your JavaScript on their site. But one way to maybe get around this policy, like especially in financial services, like they just have flat out a policy. No third-party JavaScript on our sites. It's not, whatever your startup does, we don't care. It's not worth it. The risk is too great for us because we're banks. One way you might be able to get around this is be like, hey, well, we're playing nice with content security policy. Content security policy is telling all these browsers, yes, this is JavaScript, but all that nasty stuff like eval that's in JavaScript, you can be assured that it's not in our JavaScript because we're telling the browser, if you see that, don't allow it to execute. Sometimes this may help you get around that no JavaScript rule. Now you might read on the web or like go to one of these sites that assesses like your security health and think, oh, well, I just turn on sub-resource integrity. So sub-resource integrity is where you're like, okay, script source equals load this script, and only if it matches this hash will you load it. So if anybody tampers with it, so you're an electronic army, whoever, okay, the hash doesn't match anymore, boot it out. Sounds great. Does not sound great to your developers. This is not great for startups. Startups are shipping code every day. Your customers are not going to update that SRI hash every day. And so you're going to break. You're going to break. And there's no way your customers are going to update that hash as fast as you're moving. So this one, it's nice if you have some static JavaScript, but if the way you're delivering your business to your customers through your JavaScript, this will not be able to keep pace with you. So despite what you may hear, sub-resource integrity, not a good deal. All right, so security development lifecycle. So this is some scary stuff we got to do. The stakes are high. Our crown jewels are this JavaScript client. How do we get all these developers to like pay attention to this and take it seriously? So there's the Microsoft waterfall kind of approach. That's great for like a big dinosaur company, not a startup, where they have all this like bureaucracy and checks and balances and red tape and stuff. It's pretty easy to get your security hooked in there, the design and requirements and coding and testing phase and everything else. So that's the easiest place to like make this happen. Just check for threats to the JavaScript at every one of those stages. But no, you're a startup, you're agile, you're moving way faster than some big dinosaur, and you're using sprints. How do you get into that? Because they probably don't have those checkpoints. This is where you got to hook into their sprint planning, and it can get expensive, but hooking into the sprint planning and the sprint review meetings and see like what are these teams going to build and what did they just deliver, and then you can just report like how many things there did they catch on security. Now Kanban, like this is even faster, so even faster startup. Agile's too slow doing all those meetings and stuff like planning. Who does that? So Kanban, you're just all these things are flying by and being shipped constantly. You have no idea what's going out when. So how do you tap into that? This is really where like I think the like it's going to come down to building a security culture at the organization. So this it's all about like influence and influencing your developers. So this is like making security cool within your organization. So you could have a security team and they could be reviewing everything, but if they don't hear about all these things to review, they're not going to catch it. So by influence, your security team shifts their attention away from reviewing into building culture. So this can be all kinds of things. Just to give you a quick rundown of some samples of this, one is security t-shirts for everybody. We have some pretty cool security t-shirts we give out to everybody who does anything cool with security, but they're hard to get and people actually ask for them and makes them want to do security things. Another one's a rotation program. So this is where, okay, you have a security team. It's hard to find security engineers. And you're a startup, you don't have a lot of budget, but it is relatively easier to find software engineers. These software engineers don't want to be a security career path, they want to be software engineers. But one of the like tours of duty they need to do in their software career is learn about security. So a lot of them are eager to get that merit badge. Another is like if you're starting out in your career, you may be assigned to like one team and you only work on one part of that big architecture day after day. You don't get to see the big picture. And so a really compelling pitch to help out with security is, hey, you get to see the rest of the business this way. You get to work in the rest of the systems and see like what does the whole startup look like. So doing a quarter or two tour of duty on the security team, having the engineers rotate in, they learn about security, maybe they fix some things, and then they go back to their team, all of a sudden they're the security expert on their team. You build up this satellite network of like security missionaries. There's a great way, like going back to that influence, you can't catch everything that's going on. Maybe your dashboards don't see everything that's going on because you don't know when a new team's going to spring up over here, or a little like Skunkworks team's going to go over there. But by building this network, you can get more information coming back to the security team. Now, with how do you get that information? This is just like visibility is like huge. So you could spend your time at your desk like building like a new security framework or tool. That makes sense at like a much larger startup, but when you're small and you know everybody on a first name basis, like talking to them regularly, just trying to get as much like security information flow back to you as possible is super key. So just talking to developers about their projects and bringing things in, like as soon as you hear about something, drop it in your Jira, your ticket system, and then all of a sudden you have a backlog of what all you're looking at. If engineers, you're having trouble talking to them, alcohol. It's great. Buy their bar tab, invite them out. You can throw parties, security budget, get a bar. You could have a bar in-house, go out to a bar, whatever. But like talking to people, tell them cool stories about Black Hat. It's a great way to get the information flowing. Now, no matter what you do, like I do highly recommend two things. One is a design doc. A lot of startups won't do design docs. Security is a great place to get them started. Just throw up the simplest friggin' design doc, like one page. Nobody wants to fill out a book. You just want to facilitate a discussion here. So like be very clear, like we just want design docs to get the conversation going. And so the design doc could be as simple as like implementation plan, security. That's it. That's it. It can grow over time. But like even something that simple, like just to get them to put their thoughts down on paper, like engineers like to do that. Oh, and by the way, answer some security questions too. It's a great way to get started. It's that easy. That way you don't make it intimidating. You don't give them like some 20-page document they got to fill out. Just something really simple. What are you going to do? And by the way, what's your plan for security? Now with code review does not scale, but it is important to do it in like key parts of your code. So like I would highly recommend setting up rules on sensitive parts of your code. So anything having to do with like building that JavaScript or pushing it out to the CDN or authentication, like those are the places you definitely want to know about in code review. But everything else, leave it to those security teams. Give them some, or leave it to the engineering teams. Give them some security training. Get your network of those missionaries going by having them rotate through your team. Get some good tools, and that scales much better. With code review, like you could spend your time code reviewing, but like catching the millionth XSS, like you're still just going to be treading water. But code review, like cross your fingers with that, but invest that time building out content security policy. Hey, then you have something across your whole site dealing with cross-site scripting. All right, now bug bounty. Some quick thoughts on bug bounty. So you may think, okay, let's do a bug bounty in this crown jewel of ours, the JavaScript. So we tried this. $1,000 bounty for a bug in this JavaScript client being served all over the web. Nothing. $5,000 bounty for finding a vulnerability in this JavaScript. Nope, still nothing. 10 grand, I don't know. That's the next step. We're going to go at least 10 grand, probably the next couple weeks. But I will tell you what works better than that, which is just bring in a skilled consultant. You get what you pay for. And here we're looking at like, okay, does 10K find like one bug? But I know if I throw 12K at like a skilled consultant, I'm going to find multiple high severity bugs. So I think this bug bounty is kind of like running into its ceiling of being economical. I'll tell you a funny story here. So like, Optimizely launched this bug bounty program, and we paid out $1,500, $100 for high, medium, low bugs. And so we got lots of low bugs, almost no high bugs. And so it's like, okay, the incentives are not right here. Let's jack up the high severity up to 5,000, and let's drop that low severity down to 50 so people stop sending us this like low severity noise. Guess what happened? We got way more low severity submissions after cutting it in half, and we still didn't get any high submissions. Like, what's going on? So I think that 5,000, it bought us visibility. Like, hey, look at this bug bounty program over here, not all the others. But it did not get us those high severity bugs that we were looking for. So interesting thoughts there. TBD how bug bounties play out in the long term. It's unclear if they're worth the trouble. All right, so that's on best practices, but we got to sell this stuff and make money. And so how do you sell this internally? So like, you may be sitting at your desk hacking away with engineers, but like there's a whole other part of the company that you should be talking to, and that's sales. So enterprise SaaS, specifically, we're talking about enterprise SaaS here. We're not talking about social network or some consumer-facing thing. We're talking about businesses selling to other businesses. And you have a lot of touch points with those customers in your sales and support organization where you can learn a lot about security. And believe me, it comes up a lot. Now, when you're a small startup, let's say you're doing deals of like size 30K, maybe they ask some questions about security and you say, hey, we use SSL, we're good. We use TLS, or hey, we're built on AWS. Go look at their security. Like, we're done. That might get you by a 30K deal, because it's just like one employee who's buying it, and it flies under the radar of like their director having to approve. Now when you get into like, let's say a $100,000 deal, okay, now that's going to get those additional checks and balances in place. This is where the security team of your customer is going to come in and say, hey, here's 1,000 questions about your security. Why don't you go ahead and answer those? So your sales engineering team is going to be dealing with the burden of these questions. But out of all these questions, maybe you could help them out with a FAQ to answer them. Like the CAIQ is really good from the Cloud Security Alliance. But you can also pull out of that. So like these questionnaires, 300 questions, right now we only answer like yes to 100 of them. So like those other 200, there's your security backlog. Tie those back to like your threat model and your risk, your backlog prioritized by risk, and now you have like, hey, here's what customers are asking for. And now you're not the security team, but you're the security team acting as product managers. This really helps getting all this nice security stuff prioritized. Now going further, let's say you get up to the $500,000 deal. So now it's starting to get real. This is where not only you have that questionnaire, but your contracts are going to start having security addendums in there. And it's not just going to be like answer some questions and say you do this. You're absolutely going to have to do it because it's in the contract. This is great. Like, if you can find out about this, talk to your legal team, get a good rapport going with them. Maybe give them an FAQ for the security addendum. Hey, here's how to answer these things. You can start collecting evidence there, building even more case for why you need this security. Because customers, they're going to drop $500,000 on your product. They're going to expect you to have OWASP top 10 awareness and mitigations in place. They didn't expect you to have all that availability to deal with those outages. They didn't expect you to have code reviews and web app security testing tools in place. All this is getting in touch with the customer and say, hey, this is what the customer wants, not what the security team wants. So out of this, like, you get security features, that's great. Compliance, nice thing about compliance, it opens up deals. So like, you want to, let's say your company is doing those $500,000 deals. If they want to take the next step to that $1 million deal, they got to start taking this compliance stuff seriously. So like ISO, SOC, PCI. If you want to keep doing business in Europe, you're going to have to start looking at privacy, and so that can have a lot of overlap with some of your security objectives, specifically around TLS, so encrypting this sensitive data in transit. And then getting the right frameworks in place. So like, some customers are actually starting to ask about like content security policy now. All right, so looking ahead a bit, like what's next for like enterprise SaaS startup? A couple things there, and if you know, like, if you have some good thoughts on this, I'd be super interested in what your experience has been with them. But like, first off is anomaly detection. So like, I know I'm serving this third-party JavaScript, all these sites all over the place, but how do I know it's like my JavaScript and not somebody else's? And as we know, sub-resource integrity won't work because this JavaScript's changing all the time. So like, how do we do anomaly detection on that? TBD. Privacy. So like I mentioned, I'm sure some of y'all have heard of GDPR, the big new privacy regulation in Europe, but like, how do we keep sending this business value down through JavaScript without doing creepy things that run afoul of the law? So like, could we use like a privacy preserving Bloom filter on the client or something to do like a lookup without compromising privacy? And then insurance. So like, cyber insurance is a new thing, but like, for a startup, like, they're gone if they get compromised. Like, so how could you make an insurance market for this? Like, how would you underwrite insurance for this kind of a startup? I don't know. It's a new space. Maybe it's a startup opportunity. All right, so wrapping up today, a couple quick things to remember. JavaScript integrity, that's your crown jewel. Make sure you're watching its integrity end to end. TLS by far is the primary thing here. It cuts out so much of the risk in that threat model. And awareness across your development organization, that's absolutely key to getting the security built in end to end. So remember that bar tab for engineers. If you like this, you can check me out online. Optimizely, we're always hiring, looking for security folks, software engineers. And this is a dog presentation, so there's my dogs. Any questions? Please come up to the mic for any questions.
Thanks. Hi, Kyle. Larkin Ryder from Slack.
Larkin.
How you doing? Good to see you again.
Yeah.
Great presentation. Thank you for that. My only question is if you wanted to recommend any of the tool vendors for third-party vulnerability scanning?
Yeah, third-party vulnerability scanning. There's two that we're using right now. One is SourceClear for Python, and then SourceClear. They changed their name to like Words recently. That one works great for Python. And then SNYK, SNYK.io. We use that one for scanning JavaScript, and I believe they have Python support now just recently, so looking forward to check that out. SourceClear is cool because it does what I mentioned where like it'll go look if you actually use that vulnerable code, and SNYK's good because it will actually offer to patch your JavaScript vulnerabilities for you. SNYK, SNYK.io. Cool. Any other questions? All right, thank you very much, everybody. It's been a pleasure.